glance at the Java Performance Toolbox, and it's gonna be like 15 minutes talk as we agreed before because we had to do this some small last minute changes in our schedule before the conference, but we can probably reuse some of the time from the break, which is good. And my pleasure to welcome our next speaker, Senior Developer Advocate at Oracle, Java Champion, Anna Maria Mihalceanu.
Hey.
Yes.
Hello,
Welcome,
everyone.
Anna.
Great to be
Hi.
here.
Nice
was watching
to have you here.
Simon's presentation. It was really, really, really cool. But we have to dive into mine right away. I'm sorry, folks. Yeah. So
Go for it.
it's also it's also connected to JDK 21, but it's with more action and with more code. And I hope you'll like it as well. And yes, if you have questions or comments or feedback, I'm looking forward to those. So this is where you can contact me on Twitter. My handler is Ambra1508, or you can write to me on Mastodon and give me questions. I'm looking forward to answering to them. But in today's presentation, I would like to talk to you about the JDK tools that you can use when working with Java in general, but also when you're working with Java and containers. So the approach that I'm going to share today is particularized for the case when you want to work with Java and containers. So I provided some examples and code for you. Code will be shared at the end of the session. Now, the session is trying to address a few questions like you see in the slide here. And the idea is that we would like to do a lot within the containers, but using the current JDK tooling. And we have a few options about that. In the current session, we're going to address that, and also we're going to look on how can AI and machine learning can help on that, because the topic of Devoxx Ukraine is related to AI as well. So first topic, how do we use the JDK tools for containerized applications, and what tools are available there when it comes to working with containers? Now, when it comes to working with containers, we always start with a question like, which tool builds the most efficient container image? And if you're using ChatGPT, if you're using Google, or any other places where you can search for information and your knowledge, you realize that the answer is it depends. Because again, it depends on your knowledge, on what you feel comfortable to use. Because nowadays, there are a multitude of tools to work with containers and to build an OCI compliant image. In the slide here, you just have the tools that I personally have tried. Recently, I tried even more, but I just didn't want to fill a slide with a lot of tools that probably some of you will not be interested to use further. But give it a try to these. They're pretty cool to work with. And yes, there are a lot of, I think nowadays, that's like 12 options to build a container image. But I think we all started with the good old Docker file, right? So we all started writing a Docker file to containerize our application. And historically speaking, it had similar contents to this. Now you can see here that I'm using JDK 10 and I'm referencing JDK 10, actually the GRE from JDK 10. And the reason is because, well, told you in the beginning, we aim for small container images, right? And with small memory footprint, but they're the ones that start really, really fast, right? And historically speaking, when we tried to achieve that with Java, we were running our Java only with the GRE because we only needed the Java runtime environment. So we started with a small base image, to contain the container image size. Then we also have this small image because we also want to have common layers. So we pretty much use the same from for our Java applications. We don't have multiple froms, so that we have some consistency across the layers of our images. But moreover, when going further, we were using and installing only what was strictly needed. However, this situation is for JDK 10 that provided a GRE. What happened is that in JDK 11, the GRE was not provided anymore with the JDK, right? And yes, this comes as a shock for many people, including for some of my friends. And the question is, so where do you find the GRE now that is not provided? Because you for sure need it, right? Especially when you're building container images. So the answer is by creating your own custom Java runtime for container images. Of course, there are people that already built that, and there are some repositories available. But if you just want to make sure that you're building your own with only what you need, I'm going to give you a solution for that. And the solution is called JLink. JLink is a JDK tool that you can use to assemble and optimize a set of modules and their dependencies into a custom runtime image. Now, if you're wondering what JImage is a special file format that you can use to store class and resources files for multiple Java modules to support the custom GRE. So how JLink packaging works? Well, JLink packaging looks as follows. There's like in the legacy JDK image, used to get the GRE, the bin, and the lib. Now, starting with JDK 9, because JLink was not out of the box introduced in JDK 11, was present there since JDK 9, you can use JLink to create a modular runtime image. So how does our Docker file, our good old Docker file, look if we would like to migrate it with JLink? Well, from my point of view, I prefer the two-stage approaches. So first stage would be the runtime stage build, when I'm using from a JDK-based image, and I'm creating my own custom GRE with JLink. Now, the second layer is the application stage build, where I'm just using the operating system like I would use on my local, copy the custom GRE, copy the artifacts of my application, and then run my application. That's very easy. So let's look in detail. In detail, that would be like this. The runtime stage build starts with, well, the from, and you can see here that I'm using the JDK 21 image. We can also use the same one, and I'm going to provide the source code for this so that you can build your own. And then I'm adding the modules and providing some customization to the JLink. Let's look further. First customization is the add modules, because you need to add modules that your application is using. And some of you are going to ask, like, okay, so how do I know which modules do I need to add? To answer that, you can use a tool called JDAPS. JDAPS launches the Java Class Dependency Analyzer and can give you the exact tools that your application is using. Now, in case of my Spring Boot example, I've used JDAPS to find out the modules that I need for my application and nothing else. Then I'm using the no man pages and no header files because I don't want to have any man pages and header files with my generated GRE. And the compression level is zip. So I set it to compress level 2. Now that I've done with my stage build, the application stage build is going to use the previous generated GRE to run my application. And then if I need to customize my application, I can also use this environment variable JDK Java options to customize the JVM flags at the runtime. So I'm not all the time going in code and complicating my life, but all the time managing this via the environment variables. For example, from Kubernetes propagating to the container and then to the application. And of course, the command to start my application is an entrypoint.ch. That sounds good. So let's see our application and how does that look like. Okay, let me see if I can find my mouse. Found my mouse. So my application is simply doing some to-dos, and it's a Spring Boot app running on JDK 21 that has a simple controller that manages the to-do items. So this is the standard API, the standard to-do, add to-do, edit to-dos application with a few tweaks. And of course, I have my Docker file as described earlier with my, let me make this bigger, with my from container image. And then I'm building my GRE, then building using my application and how using the runtime to run my application. So this is pretty much it for running my app. Now, if I'm going to the Docker Compose, because I don't want to use Kubernetes for this one, I'm just going to quickly spin up a Docker Compose setup. I have my application that I can all the time build from my local. I have some Java options here, just in case. And of course, I have another setup to Prometheus to have Prometheus pull my metrics from my application and Grafana to interpret my my metrics from Prometheus and having Prometheus as a data source. So without further ado, let's go here and start the current application. So with the minus minus build means it takes the current context and it builds it. So let's spin it up. Hopefully it's not going to take too long to be pulled all. Okay, so my application has started. Let's go to the browser. Set looks a little bit easy to manage and so on. Now, every time I'm creating a to-do, I add a tag to it, right? So I add a tag, it's behind the scenes. It's not something that you can visually modify. So let's add some load. And I have a small script to generate some load to my app and to give more complicated parts to it, so that doesn't be not having just one user. I just want to have multiple users sending requests and making my application busy. And in between this, I want to see how much memory my application is using. So I have a script that I have from an article that one of my colleagues has published, and is pretty cool for monitoring PSS memory usage by process. So in this case, I'm just going to use my script to start this one. So to start the script, let me just remember, well, how is my, cat, I think is print PSS, that's H, and then docker exec -I to the Spring Boot to do service bash. So this is the way that I can get in my to-do service and see how much memory is being used. Now, looking at this and monitoring the PSS, I want to see if there's an increase or what's the fluctuation of the memory that's being used here. So I can see that there's load happening, my memory is increasing, but I expect also to decrease at some point. Then I'm going to add a few more users to this. And I want to see that, I don't know, that at some point there's something happening. So there's a fluctuation, like that the memory decreased here because the garbage collection entered. But I can see that now it's increasing and so on. So my application is under stress, right? Well, my application is under stress, consuming a lot of memory. And if my application continues to grow, but the memory doesn't get freed up, or the free up of memory is very small, and in this case, it seems to keep growing and growing, which is alarming and might be a situation when it gets into out of memory. So let's see, maybe I can fine tune the JVM flags. So how to do that? If I want to make sure that I'm okay with the amount of memory I gave to my application, I can track the memory with a few tools. So memory is split into parts. The memory that the JVM process is used to hold the Java objects, the heap memory, and the native memory, which is the memory used by the JVM as it runs on the operating system. Now, to track the native memory, you can use JCMD, another JDK tool. You just need to add it using the module jdk.jcmd to the list of modules you had before, and that's it. The reason why it's not going to be detected by JDEPs by default is because this is a tool that you can live without in general in your application, but in case of diagnostic commands, you need it. So how do you use JCMD to track the memory that you're using? Well, you can use JCMD all the time, but overusing it is not okay. But you can also add it as a flag. And the native memory tracking flag can have three values: summary, detail, and off. By default is off. So I'm giving you the example on how you can set that. But moreover, the tool itself is useful when you want to compare the certain point of the memory with the state at another point. So to give you a diff on that. So to get that, you can use the native memory baseline and the native memory diff. The diff can be used to observe the change, where exactly the memory is being used. because over time, the GC works notice an increase and decrease in memory. But if it's only, this could be a memory leak issue, right? So dump, by the way. So let's go here and see how our memory is doing. And we can see that our memory keeps increasing. At some point, some space is freed up, but not enough. So let's investigate further what's going on with our application. Okay, in this case, I have my track.ch script where I'm using JCMD to exactly do that. So to do that, just going to go here and say track.ch to see how memory is tracking. And of course, wait a few seconds. But I think that this didn't work. And the reason is because I might not have the JCMD enabled. So how do we enable the native memory enable? So as I said, the native memory tracking. So I can do that in a couple of ways. Sorry, not the script clear. Sorry about this. The script that I'm using that is flag.ch. Okay, so you can do that by first checking the GCMD, the PID of your virtual machine, and the VM.flags to get all the flags that you're using. To get all the flags that you're using, you're going to get them sorted in alphabetical order. And the native memory tracking, because you can see, is not present there. Now, if you're just going to say run GCMD to see native memory, you get the message that the native memory tracking is not enabled. Because I don't know by heart the native memory tracking flag, and maybe you don't want to remember all the details, you can use a tool called jinfo to find out how to set it up. So I'm just going to copy paste from here. I'm going to go to Docker Compose, enter a new line, and put it here. And of course, not on off, but on summary. I may stop the load because it's not going to be effective, and I need to restart my container now with the native memory tracking on. So now that we have the native memory tracking on, we can run our track query to see how much we're using. Okay, print PSS has stopped, and I also want to simulate a few more stuff. Okay, let's run to you again. Print PSS to see the memory. Not this one, sorry. This is for local that I'm using. Okay, this one for the Docker container. Now that I'm printing this, and now that I want to track my native memory, I'm creating my baseline, and I am waiting for 10 seconds until the snapshot for the diff is going to be taken. And yes, I want to run a diff, and there's a summary diff here. What do you need to look into the summary diff in case there are issues with the native memory? You need to look at the increases in the usage of, let's say, allocation of classes, threads, like a lot of threads being spawned in 10 seconds can give you an idea that something's wrong with the native memory allocation. Or with the other places, like how tracing or the save points is added. So you get all this information. But in our case, it seems that there's no issue with this. However, the memory is kind of a lot working and is eating a lot of it and is keep increasing. So if I'm adding even more load to this, is going to keep on increasing. So let's see why is that happening. Going a little bit here, I want to also add that you can go and use these tools like GCMD also with remote access if you're in the GMX monitoring and remote access to an access port. And this is to enable that remote access port. Well, this is how our application is behaving. So we could get also statistics about our running Java processes because we're using a lot of memory, but maybe we're not convinced and that it's too much given the current workload. So we can obtain statistics with a few tools. We can use GStat, like the name is saying, it's generating for you statistics. It's, the GStat minus GCUDL command keeps you running for a certain amount. Tool that you can use is JMap. The JMap command line utility prints memory-related statistic for a running virtual machine. And in this case, it's printing a histogram of the Java heap for this Java process. This is the Kubernetes command that can be used to it, because locally you can use directly these tools. So without further ado, let's go into our code and use GStat and JMap to look into more of these. So let's go to query. Information about how the garbage collection. All these queries are being provided to you in the repo. So it's all there. So in this case, the JCUDL is taking 500 samples every 50 milliseconds. And there's a header printed every 10 lines in the recordings jcstats.txt. So it's present there. Okay. Let me go and okay, and just hope that my application, okay. Thought it phrased for a while. Okay, so now there's also the JMap command in the behind the scenes. Now, if we're looking into this file and what was generated here, we're looking actually mostly at these two columns, E and O. E comes from Eden space and O means from old space. So promotion of objects from Eden space to old space. And we can see that promotion of objects and utilization there. But the promotion of objects, you can see that the garbage collection takes a while, like 12 milliseconds in this case, to promote these objects. And that the promotion time seems to be there and quite increasing and going and going. And although the garbage collection works quite often, the memory still keeps increasing in our case. So there might be an issue, and we see that maybe it's too much memory allocated and the garbage collection doesn't have time. So what can we do in this case? Like, how do we go further from this histogram to more information about what's going on with our objects and identify the problem exactly? By the problem, we need probably to look into profiling our application, and we can use for that the JDK flight recorder. Again, if you want to add JDK flight recorder to your containerized application with JLink, you just need to add the jdk.gfr, and you're adding the module there. To start GFR, you have several options. So there is an option to start it with the -XX flight recording, or you can add more details to that. But you can also use GFR with JCMD and use JCMD, the ID of your JVM, and then use the GFR invocation of action that you want to use. So if you already started your application, you can still use GFR if you're having JCMD attached to it. Then you can also start recording with default settings because you get two profiles with the JDK, but you can also have the profiling with your own custom profiling. In my case, I used a custom profiling, which is also provided in the repo, because I wanted to capture a few more things related to memory, since I already feel that there's an issue with my memory. Let's go here and use GFR. So I have a little script for GFR as well. But before going to that, I need to customize my GFR and I need to add it here and enable it. So the way to do that is by adding the access start flight recording. So I want to start my flight recording and all the time to put the information in the recording.gfr. Use the profile, my profile.gfc, which I have in my repo. And of course, use the max age of 5 minutes and dump on exit true. So if I am to start this, I'm going to start, dumping information in GFR, and then I'm going to get information about my recording and how things are going. So let's go into what's happening with the GFR and what the commands are executed here. So in this case, I'm firstly saying do a recording dump for me. But before doing the recording dump, after doing the recording dump, I want to also look into what are the most executed memory, what is the most executed method with the hot methods. If there are any memory leaks, or how the allocation by site is going on. And this command, GFR view, is a new command that was added to GFR in JDK 21. So it works starting with JDK 21 and can be used to gain information from inside your JVM using GFR on spot. So let's see what this printed. So first of all, let's go to allocation. Didn't. One sec. I think I know what I forgot. I should have moved my profile next to the scripts. Okay, sorry about this. Docker. It's going to start it again. Come on. We're going to start our container again. Let's stop the load for the moment to give it time to recover. And you need to stop things, and they don't want to stop. So our application started again. Okay, good. So now that the application is started again, let's run again the record.ch with the correct profile set there to profile it, but also the allocation. Good, now it's better. So looking at the allocation part, we see that it's a lot on the with arrays. So there are a lot of arrays being worked up here. And if you're seeing that there's one of your methods from your own application being frequently used, you can also make that use so much. Moreover, if you're if one of those classes use so much and it's allocating that much memory there, then if you're looking at the most used methods again seems pretty harmless. So it seems that everything's okay with our application, and with the memory leaks, seems to be really, really fine on everything. Now, seems to be like pretty okay. Let me run it again and take another recording of it, because maybe there's not enough load that we can look into that and get into it. Good. Now, and if we're having this, we can also look at the recording.gfr. So what our application, how it was profiled, and so on. And for that, we can use JDK mission control to look further into our stack. And if we're going to look into our stack in here and in its allocation, we can see that that's the Hibernate mapping model creation helpers is the one that's being used very, very much and intensively. And with GMC, you can always see a stack trace in memory when you're opening your recording, and you can look into the details of the stack trace and when that is called. And now I see that I get here to the update to do item, and I'm going to choose the next frame because this is my method, right? So I want to see what exactly to do item is a problem. Now that I jump to the next frame, I'm going and seeing that the add new to do item update is getting to add somehow is allocating memory. So it seems to be going pretty. I'm going to choose the next frame. It kind of seems I cannot go further with the next frame in this. So if I'm looking, I'm just going back to the previous frame. Previous frame is on update. Okay. And if I look down, I can see that simulate overload is also a culprit. Let me check the simulate overload. Maybe it's something there. Now, so simulate overload is going on update to do item, and then it's calling add new to do item. Interesting. Let's go to the application a bit. So going here on my simulate. Yes, I'm getting all the data from the repository and I'm updating my data. Okay, this is what I'm doing. I'm updating data. That's what the stack trace was saying as well. So I'm updating an item, and if an item is present, I am just saving that item over there. So, and I'm saying that entity was updated. However, if I'm looking at how I'm saving this entity and thinking about, okay, what could have caused so much memory to be used? And looking again at my allocation, I can see that the map is now the one that is getting mostly of the parts. And if I'm looking to the other ones, it seems to be okay. So looking back in here and how my items are being saved and so on, it seems that everything is quite okay, but my memory still went up and up in this case, right? So all the time went up and up and up. And the amount of requests was kind of constant. So it seemed very weird for that to happen. Now, what happens is that my code does have a memory leak. And to justify what was the issue with that specific memory leak, the problem is as follows. So is this situation when I'm adding here information. So I'm adding a tag, as I said in the beginning, for each entity that I save. Now, when we pass key and value objects to the put method on the Java hash map, the hash map implementation calls hash code method on the key object and applies the return hash code on it into its own hashing function to find where to allocate that, right? Now, the thing is that we're all the time using map entry in that bucket to find another object. But when we're going and updating that, we're actually modifying that object. This means that that map has lost a key because that object that we had initially is now modified. So we kind of lost a way to access that initial object. But we also need to store information about the new object. So what this means is that we get a new key, but we don't find information for the next key. So in this case, what happens is that the map keeps growing and growing and growing. And even if I would delete information from the map, and I'm doing this by using text.remove here, that would make only an effect on the last key that was present in the map, the last updated value that the map had based on the hash code of the object, and not for the other ones. So that's why my memory deallocation is not that great. Good. But this was like point-to-point information. So I knew I had a problem. I knew what tools to use. It's good that I know how to profile. But how can you get information on the events that you don't know about, right? So for this, you can supervise what's going on with your JVM using GFR streaming events. So you can stream selected metrics to your monitoring service using GFR streaming events. So for example, in my case, in my application, I'm using a metrics registry, and I'm registering a specific, in my case, Gosh, to that metric registry to get information on how the memory is allocated for my application, and I'm sending that to, in my case, Prometheus. Moreover, I can send, average, min, max, whatever you want for that specific JVM metric. So you can correlate these existing JVM metrics that are provided by the JVM via the GFR streaming to your specific applications. And you can correlate this to the other data that you get, for example, when using micrometer regarding your requests that are made to the application. Moreover, you can expose GFR data to other management APIs. So you don't need to use all the time just the existing providers and so on. You can also use the remote recording stream to do that. So there are multiple ways to use this API. It's a very powerful API. And there are also products in the market that have taken advantage of this to stream their data to specific providers like Prometheus. So this is how you get information on the long term about what's going on within your JVM, as long as you have -XX, the GFR enabled, GFR flag enabled for your app. When not to use GFR streaming. So GFR streaming is for getting information about events all the time, right? But if you need to profile your application, then you also use the commands, the GFR, in my case, the GFR view or the GFR dump, to dump a recording and to inspect that recording further in JDK mission control, for example. And from what I understood, also IntelliJ nowadays has a great support for looking into the GFR dumps. So this is when you should use it. Like when you need to get min-max averages, you should use the GFR events and stream them to your monitoring system. But if you need on-point information, like what's the state of your JVM at a certain point together with the application, you use the GFR dump recording part. You can also make your own custom GFR events by making your own settings by extending the JDK GFR setting control. And of course, you have to give them a proper name, label, and so on, so that you would know how to find them in your recording. But also, and you can create your own custom event by extending the JDK GFR event. And of course, you can register these custom settings via the settings definition interface. In the settings definition annotation. And for my application, as I said, is a Spring Boot. If you need an example on how do you bind all these together, so for example, for my application, I just created a filter registration bean, and I set my flight recorder filter, where I'm filtering for my specific events, and added, of course, which URLs do I want to supervise for for those specific recorded events. So you can customize on which paths we want to record what as well. Moreover, for my application, I just needed to listen for what's happening. So I used this this new custom metrics listener and I registered it accordingly. And that's pretty much it. Now, in the code that I've given you, you have the filter and you also have the custom metrics listener. At start, let's looking once the context has been initialized. So once the context has been initialized for my Spring Boot application, I can look into what's going on there and make my own custom metrics. Now, if I just want to use the out-of-the-box metrics, what I have done, I have just looked into the application startup part and overridden that. So when my application is ready, I'm just getting all the information for the JDK events there. And you can find this in the code. Now, since we're at AI event, how can AI and ML help all this kind of setup? Now, in this kind of setup, usually you have multiple applications that the Prometheus or another monitoring service is looking over, right? And it is pulling metrics from all these applications. Like in the example here, there are multiple targets which Prometheus is pulling information and metrics. These metrics, for example, in case of Prometheus, can be exported to different third-party exporters. And Prometheus gives a lot of these exporters and its integrations and how to do that in their documentation. Moreover, once you store that information here, what you can do with machine learning, for example, you can query a Prometheus and learn from that query, compare with your existing stored values in the exporter, and predict what's going to happen next. So the way that you can use this is by comparing the exported metrics to the ones that are in the query, and React create new alerts based on this forecast. So you can kind of forecast the future based on past learnings and current state as well. And an example of like how people have thought also how to use ChatGPT for that, I found a little example on GitHub where the creator has used ChatGPT to created a ChatGPT bot for Kubernetes issues. So you can ask the AI to solve your Prometheus alerts, well, of course, getting the best responses and so on. But it's possible to integrate this and to have it more present in your application as well. Now, Prometheus gives a lot of information on how you can integrate with it, and it's pretty cool on how many things you can do with its exporters furthermore. Now, without further ado, this is where you can find the code. Thank you very much for listening to me, and I hope you find this presentation insightful. Now, I don't know if we have questions or how we can handle the questions. If you can help me, Oleg.
Yes. No, first of all, thank you very much for your presentation, Anna, and especially the last kind of example that, I mean, it's kind of it proves that with AI we actually can do a lot of things, and actually like you're probably limited only with your like imagination what you can do with that, and you can of course plug in different systems like together and make the best benefits from that.
Sure.
And by the way, one funny thing was is that during your presentation when you were like loading your system and coding, there was like a small lags of the kind of voice and the video. So that was like a funny because your machine was kind of loaded, and the support guys told me we can't do anything because the Anna's machine is 100% like loaded. CPU is 100% loaded. So you've been working too hard,
Yeah.
Anna, for today's presentation. So let me check the questions. No, I don't see the questions, but maybe you can like have a look at the chat in the platform. Maybe someone will like post their questions just in
Okay.
a few minutes, maybe. So just if you
Yes.
can keep an eye on that, right?
Would be. I will. I will. Thank you very much. Thank you very much
Cool.
for having
Thank you.
me, and
Was my
enjoy
pleasure.
your break.
Cool. Thank you very much.